And finally, I'd like to introduce our keynote speaker, Dr. Lisandra Garay-Vega. She is a transportation safety specialist and division chief at the Transportation Safety Board's Office of Highway Safety. Dr. Garay-Vega is an independent, National Transportation Safety Board is an independent federal agency that investigates significant accidents in all modes of transportation, determines the probable cause, and issues safety recommendations to help prevent recurrences. Her division is responsible for researching and developing national highway safety issues and managing the development of crash investigation reports and safety recommendations. Prior to her current role, she worked at the U.S. Department of Transportation, National Highway Traffic Safety Administration, or NHTSA, Office of Crash Avoidance Standards as a supervisory general engineer. At NHTSA, she led the strategic and operational activities of the Vehicle Dynamics Division towards the development and production of standards, regulation, policy, and guidelines for the safe and efficient use of motor vehicles in the United States. And in a Safer Sim connection, she earned her MS and PhD in civil engineering from the University of Massachusetts Amherst, go UMass, and a BS degree in civil engineering from the University of Puerto Rico, Mayagüez. Yay, UPR. In 2015, Lisandra was recognized with an Outstanding Alumni Award. Recipients of this award are, quote, worthy ambassadors for the UMass Amherst College of Engineering and have shown extraordinary effort and notable success in their early careers, end quote. So at this point, I'd like to welcome Dr. Garay-Vega, and I'll turn the floor over to you.
Thank you very much. Let me just open my video here. Congratulations to all the award recipients. What a fantastic team you had. I hope my audio is coming out really well and the video as well and the presentation. Let me know if are there any glimpses there, please. All right, so I'm assuming everything is going well.
Mm-hmm.
All right.
It looks great. Looks great.
Excellent. All right, so first I want to say congratulations to the award recipients. I want to say thank you for the opportunity to be here. To be honest, it's a pleasure. Thank you, Don and Jacob, for the coordination and the invitation. Dr. Noller also at UMass for the invitation. It's an honor. I accepted this invitation for several reasons. First of all, I share your commitment to improve transportation safety through collaboration and through multidisciplinary research. I'm very impressed by the type of work that you are all doing to improve safety, and it's great to be part of your events. And I also feel that I have a strong connections, as Don mentioned, with the institutions and the people that are represented in the consortium. And what I figured I'd do as your keynote today is share a little bit of knowledge or tips of information, lessons learned from my academic and professional career. And hopefully, especially for the students, you can get some few nuggets of information that will help you navigate your academic and professional journey. So with that, what I'm gonna do now is I'm gonna share a little bit of my background, and then I'm gonna transition a little bit into the subject of emerging issues, and hopefully that will generate a lot of discussion towards the end. All right, so as many of you know, I completed my undergraduate degree at the University of Puerto Rico, Mayagüez. Un saludo a todos mis colegas en Puerto Rico. And I had the great opportunity to work with your distinguished faculty, Dr. Valdez and Dr. Colucci, as an undergraduate research assistant in some projects, some of the other wonderful activities that they were doing at the time at the University of Puerto Rico. And those instances, those experiences opened the door for me for exploring what transportation safety was and exploring the options, what was possible as a civil engineer. Transportation safety was not in my radar until I get to know Dr. Colucci and work with him, and then also with Dr. Valdez. So I really appreciate those giving me the chance to work with you on those projects, because that was the beginning of everything for me. At the time, as an undergraduate student at UPRM, I also had the honor and privilege to attend a summer research opportunity and internship at UMass Amherst. And that experience changed my life in a good, positive way, as you will see. It was very challenging. It was very rich. And I think at the time, for me, it was another eye-opening experience, because I saw that at UMass, transportation safety was somewhat more formalized. It was not an abstract concept. It was not kind of an afterthought. It was not a catchy phrase. It was actually a real thing and a potential area of specialization for me. So during my internship, I had, again, another privilege of working with great people, including Mike Noller, Dr. David Noyes, Dr. Don Fisher. And again, that approach to transportation safety that was happening at UMass at the time, it was a huge motivator for me. So a year later, I left everything behind, my family, the nice weather in Puerto Rico, my boyfriend of many years, my language, everything that I knew, to pursue a master's degree initially at UMass. And to be honest, I was very happy. It was a great opportunity, but at times I felt a little overwhelmed because of the change. It was a lot of cultural shock for me a little bit, plus the weather. I moved in the middle of the winter. I started my graduate degree in January. So coming from Puerto Rico, that was a real shock. But I have to say, even though I felt, as I said, happy, scared, lonely at times, what made the difference for me was that the people at the UMass UTC and HPL, the Human Performance Lab, they made me feel welcome from day one. And with time, it felt like a second home. So I felt very, very comfortable. And for many years, for my master's, and then I stayed for a PhD, I worked with Don Fisher and Mike Noller and others, doing a lot of driving simulation work. And some of the topics that I investigated had to do with younger drivers, risk perception, pedestrian safety, as well as we partnered with some of the manufacturers to study in-vehicle infotainment systems and some of the user interfaces there. So again, it was a very rich experience, but it was more than transportation safety. My time at UMass, I learned more, again, than transportation safety. It was about a global perspective. It was about community. It was about project management, time management, and all those experiences, basically, including working with cities and towns, basically testing and implementing transportation safety improvements, took me to public service, which is a change because I originally was supposed to go into academia. But again, it was a lot of different experiences, including a graduate internship at the United States Department of Transportation Volpe Center. I was honored to receive a scholarship from the Volpe Center once I finished my master's and before starting my PhD. So all those experiences basically was the beginning of my career in public service. So it seems like it was yesterday, but it's almost 20 years for me since I started working. As I said, it was in between my two degrees, but I started working part-time for the Volpe Center. And once I finished at UMass, I stayed relatively local in Cambridge, Massachusetts. And the focus of my work there as a research engineer, I study the safety benefits and the unintended consequences of emerging technologies, which is very relevant to the topics that we are discussing today. And my hope is to share some of the lessons learned from that early experience and and again, hopefully generate some discussion in that area. So again, at the time, the issue or the safety issue that was an emerging issue had to do with electric vehicles and hybrid electric vehicles, and the fact that some safety advocates identified the potential safety problem because these vehicles were relatively quiet. Again, using a very generic term here, but we all use the vehicle sounds, the tire friction to the pavement, as well as other cues to navigate. We just don't pay that much attention on a daily basis. So this was a priority project for the Department of Transportation, the National Highway Traffic Safety Administration. And my task was to assemble a research team to inform agency decisions. So it was about defining whether there was an issue and what the issue was, and then examine potential countermeasures. So this was kind of a first initial opportunity for me to stay a little bit out of my comfort zone, because I passed, my role changed a little bit from being the expert, I kind of leading one project and one research, to leading a research team that was big. Like, this is a photo of one of part of my research team. But then I also had the opportunity to work with vehicle manufacturers, safety advocates, decision makers at the Department of Transportation to develop a comprehensive research plan and to implement that plan. So briefings, meetings at the very high level to inform decision making was basically a very common activity for me. And that takes me to how important it is, how we produce knowledge as a researchers and how we make an impact. So this was my very first project that I led, and that project, it was a multi-year effort on the research side only. And then that research was used to inform rulemaking, the development of federal motor vehicle safety standard. And I work at DOT, Wolpe Center, then I work at NHTSA. So I followed this project. It was almost 10 years of my life working on this thing. But I want to highlight two things that I learned from that experience. First of all, your team, your research team, your investigative team is everything. For me, it was very important. I early on recognized that, my expertise just take me to certain way, certain position, and certain distance in terms of achieving a goal. Collaboration was essential. Understanding what everyone has and can bring to the table to address an issue was critical, especially with transportation safety issues, right? They're not easy. We need to understand the user, the machine, the environment, the policies and regulations that surround different issues. And my research team was kind of the core and the center. But for example, their areas of expertise were very diverse, from human factors, psychology, hardware and software engineers, statisticians, again, data analysts, and then the partnership with the stakeholders, car manufacturers, safety advocates, mobility and orientation and mobility experts from the blind community, several key organizations in Massachusetts and at a nationwide level. So all that to say, keep this number one in the back of your mind, because to me, it was very important and continues to be very important. So after many years working in research and rulemaking in the regulatory arena at DOT, I transitioned, and now I'm at the National Transportation Safety Board, Office of Highway Safety. And I'm leading a fantastic team. But before I move on into describing what the NTSB, what I'm doing at the NTSB, in case you're not familiar with the work that we do, I'm gonna try to play a very short video that describes our mission. So hopefully this will work out. All right, so bear with me for a moment.
NTSB's mission is to investigate transportation accidents and issue safety recommendations to prevent similar accidents in the future. The NTSB does not regulate transportation safety. That responsibility is held by the Department of Transportation. Our effectiveness is grounded in our reputation for conducting thorough, accurate, and independent investigations. We produce timely, well-considered recommendations to enhance transportation safety. This is our mission. We are the NTSB.
And we're back, and hopefully that played well. Yes? Okay, excellent. So again, as part of my work at the NTSB, I lead the information. Oops. Are we still here? Okay, let's have a clear. I just got another strange message from Zoom.
Oh,
Can you hear me okay? Are we still good? Okay,
can hear
perfect. All right. So what do we do at the NTSB? We advance transportation safety. And the way we do that is by conducting independent and very thorough crash investigations. At the Office of Highway Safety, we are only about 30 people. So 30 people for the entire country. There are not that many people, right? So people naturally ask, how did you decide which crashes to investigate? And the answer to that question is it really depends. These are examples of the crashes we have investigated in recent years, and sometimes is high public interest. School bus crashes, bridge collapses, those of course are very high media and political interest sometimes. So that we go because of that reason, or we consider that as part of the decision making. But really, most of the time, we are looking into areas where we can make improvements. And recently, we have been going out and investigate emerging issues in transportation safety. And that had to do with, for example, partial automation system, advanced driving assistance systems, as well as electric vehicle battery fires. So what I'm going to do today in this, the rest of the presentation is talk a little bit about what the investigative team looks like, and then how we issue recommendations and take that message to try to influence change. So the core of our, the foundation of everything that we do is our investigative team. And again, lesson number one comes back here. Our team is everything. And we typically deploy a team in with five subject matter experts in these areas: human performance, survival factors, highway and vehicle factors, and motor carrier operations. Now, this is just when they go into the field, they come back to DC and they still do some investigative and fact gathering activities. And we have support from the Office of Research and Engineering, and that basically is for additional technical support, such as, say, material science laboratory, the vehicle dynamics simulations, medical consult. So what I want to highlight here is, again, to examine and to appreciate transportation safety issues. We are using this multidisciplinary approach because we know that we cannot just focus in one area. There are a lot of components that either cause or are contributing factors to crashes. And that's kind of the rationale for us to have this robust multidisciplinary approach. In addition, to enhance our capabilities, we have this party system, or the party process. And basically, institutions, organizations, entities that can provide technical expertise to the NTSB are designated as party to the investigations. And there are many benefits for us and for them. So for us, basically, we have a new partner, someone who has a lot of subject matter expertise. And this is very important, especially for emerging technologies. We work with vehicle manufacturers, for example, very recently, try to understand their automation or partial automation systems. Without their involvement in a system, may have been very difficult to determine what happened or understand the facts of the crash. but they are not limited to private entities. For example, local state DOTs are often parties to the investigation, as well as our partners agencies in the regulatory arena. And the benefits, as I said, there are multiple. They can help us get, kind of have a strong record of the factual, but then because they have access to early information that is not generally available to the public at that point, they can identify corrective measures early on. And I will talk about an example where we recently have a party to the investigation make significant changes as a result of their interaction with the NTSB early on. So how do we make a difference? After we investigate a crash, my wonderful team, and this is kind of where my staff comes in, they analyze all the factual information and establish or identify issues, safety issues, and propose safety recommendations for the board to consider. Now, recommendations are basically directed to minimize or mitigate risks. And again, we don't have any authority or any regulatory power. So well-crafted recommendations are the most meaningful way where we make an impact. Recommendation, as I said, is designed to eliminate a safety risk. And it's directed to those entities that can make a difference, that can make a change. Again, it could be a vehicle operator, a regulatory agency, state DOT, or others. And this is where lesson number 2 comes in. Communication is key. For us, communication is key from beginning to end, from the point where we are out in the field, interacting with the local law enforcement and communities, to where we put everything in paper in a final report, which is kind of the vehicle where we communicate the information with the public, but then also after, when we are trying to advocate for those safety recommendations. So the power of our recommendations is not on the amount of recommendation, but how persuasive we can be in terms of leading up to that recommendation. To that end, 80% of our recommendations are adopted, and definitely we are making an impact in transportation safety nationwide. So I guess I wanted to stop a little bit and reflect on lessons number 2, which is communication. For us, is investigative work. For you, is research and development. And what we mean here by communication is not just sharing all we know, but the way that we do that, how we understand who the audience is, examine different alternative ways to say or share that message. We want to be using plain language. We want to be, again, reaching out to a wide audience, and yet we want to maintain that technical accuracy. So it's not an easy task, but I think it took me a few years to move from I need to use all the technical anachronism that I can possibly imagine in this briefing to be able to communicate in more plain language and simple terms without losing the essence of the key message. So the bottom line at the NTSB, in my view, is what happened, what we found, and what we recommended. So here is when I'm going to transition to some of the key examples that you might be very interested in learning about. So I'm going to describe some of these events, and I'm going to mention, I'm going to focus on what happened. And then when I talk about what we found, I'm going to focus on the probable cause statement that was approved by the board. It's very interesting because before we get to a probable cause, we have a lot of other findings that you might find very important in identifying emerging issues in transportation safety. It's just a lot of detail for me to cover in a presentation, but I encourage you to visit our website and examine this report in a little bit more depth. So Mountain View, California was a crash in a highway where a Tesla Model S was operating in autopilot with autopilot engaged. The vehicle struck a previously damaged crash attenuator and a fire ensued. The fire is associated with, or was associated with, the high voltage battery. Now the driver died as a result of this crash. So what I know this is a lot of information, so I'm going to highlight a few of the items here. But this is the actual probable cost statement as approved by the board. I'm going to call your attention to the highlighted text here. So what we found associated with the cost of this crash was the Tesla autopilot system basically veered the vehicle into a gore area. Instead of following a travel lane, it deviated the vehicle again to the gore area due to system limitations. Now, the driver, person responsible to take action here, did not respond at all. It was determined that the person was distracted by engaging in a game application on a cell phone device. Again, demonstrated a lot of over-reliance on the partial automation system. That was the cause. Contributed to that crash was the ineffective way that the manufacturer monitored the driver engagement with the system. And again, this goes with some of the issues that we're probably going to talk tomorrow during the panel session about driver complacency and inattention that are kind of unintended consequences of some of these new technologies. I'm going to focus on some of the recommendations that we made to address the issues that I just highlighted. But as you can see, towards the end, there are more items that were contributing to this crash. So for perspective, as I mentioned before, crash happened. There are many potential factors that impact that crash. And for example, issues of hardware maintenance and operation at the state level was also included in the probable cost, just for some perspective there. So what did we recommend in the area of partial driving automation? Now, again, this is just using very high level plain language view, but it's a result of a lot of different investigation, especially our Mountain View, California report and the Williston, Florida report, and a couple of other smaller targeted field investigations. So we asked the National Highway Traffic Safety Administration to expand, for example, one of the items was to expand their forward collision avoidance system and the test procedures associated with that to include basically things such as traffic safety hardware and other objects that are found in a highway environment. And that's just on the vehicle side, detection system. Another item that we recommended is for NHTSA, again, the regulatory agency, to develop performance metrics or standards for driving monitoring systems and to minimize driver disengagement. And in doing that, we asked them to work with industry experts in the development of those standards. One recommendation that was kind of a broader picture, broader kind of perspective on this, we also, in recommending things to the National Highway Traffic Safety Administration, we asked them to evaluate whether this manufacturer, in this case Tesla, whether their system and the limitations that we saw, as well as the foreseeable misuse, driver misuse, and the ability to operate outside the operational design domain or the environment where the system was designed to operate, whether it represented an unreasonable risk to safety. And if they do determine that that's the case, to initiate an enforcement action to trigger corrective action by the manufacturers. Some of the items that we recommended initially in the Williston case has to do with, the operational design domain, basically restricting the use of those systems to the conditions for which they were designed, as well as to improve data recording and event data recorders to better understand what happened in these crashes and whether the systems are activated and kind of facilitate a lot of this fact-finding. All right, so from California, we're moving to Arizona. And you probably heard about this crash. It happened in 2018. And this is highlighting test vehicles, and meaning testing higher levels of automation. this crash happened in, as I said, Tempe, Arizona. It was a test vehicle operated by Uber ATG. They were using a Volvo as a vehicle platform, but the vehicle was operated in what we call computer mode, or basically the self-driving system was engaged. They did have an operator in the driver's seat in this case, but again, the vehicle struck a pedestrian and the pedestrian died as a result of this crash. So what did we find in this case as it relates to the probable cause? Some of the issues had to do with the failure of the vehicle operator, not only to monitor the driving environment, but to monitor the automation. And again, we see distraction again as being one of the factors that was present in this crash, distraction by a cell phone use again. This crash was one of those situations where the operator was a party to the investigation. So the probable cause did identify that at the time of the crash, the operator, Uber ATG, had an inadequate safety culture. Basically, there are a few things that they didn't consider that were critical to the testing, in our view, of this type of systems on public roads. And that has to do with developing safety risk management plans, effective ways to have oversight of the operators, the vehicle operators, and then to address operator complacency associated with the automation. And to their credit, they work from day one to identify and clarify, aspects within their company and their industry that they can improve and fix. And they did that. And I think after everything was said and done, they shared those lessons with the industry. And so it was not only a benefit for their company, but they share what they learned and what they have done in the implementation of safety management system, basically. In this particular crash, we also highlight some of the deficiencies in the state level with the insufficient oversight of automated vehicle testing. So what did we recommend in those cases, or in this case? So to NHTSA, we recommended that they require a self-assessment report. So basically, this is now a voluntary report that companies provide to the federal government. There is no formal evaluation or approval. So the NTSB position is that those should be mandatory. And we also asked NHTSA to establish a process for an ongoing evaluation of those reports. To the operator, we asked them to continue the implementation of the safety management system. That recommendation is actually close. They exceeded the expectations that we had at the time. So a success story there. And to the states, we asked them when they are approving different companies to come to their state and test in public roads, our position is that they should first establish a task force to evaluate those applications, and those applications should have at a minimum a requirement to have a safety management plan that at a minimum, again, consider the fact that they could have a crash and that they could have operation inattentiveness, things that could be anticipated and should be mitigated, those type of risks. We also have issued parallel recommendations for different organizations to inform their members about the crash and expand the scope or the reach of our message. And we did that with the Association of Motor Vehicle Administrators so that the learnings in Arizona can be applied in other jurisdictions. So the last example that I'm going to share special investigation report in the area of electric vehicle battery fires. And I'm going to show hopefully a clip.
Hey, I think we lost you, Lisandra.
Hello.
Hey, yep.
Am
Just
I-
give-
Where did you lose me? Just now?
Yes, just
Okay.
now when you went to advance your slide.
And
Okay,
the share screen isn't up anymore, so you might have to reshare it.
got it. Interesting. All right, let's try this. Apologize there.
No worries.
No.
You're back.
I'm back.
Yeah.
Technology, we did test it. Not the same. Okay, can you see the slides? Can you hear me okay?
Yes, we can.
Okay, all right. So I'm going to show you a short video. The purpose of the video, of course, there are two. One is to show you some of the issue areas that we identify, but then also show you an alternative way that we use to reach out to different audiences. For us here, the target audience for this type of message were first responders and secondary responders, because the risk of electric battery fires affected them. And we wanted to, again, have a more accessible way to provide high technical information in a very short video that they can access in different settings. So let me play this video for you just to again highlight the issues and give you an example of other methods of communication.
And Lisandra, right now we don't have the sound with it. I'm wondering if we might need to.
Yeah, see my settings didn't transfer. Okay. Apologize.
No, good thing we're expert at doing that.
Yeah.
Let's do it again.
Yep.
One more time. If not, we can just move on. But
In August of 2017, an electric car crashed into a house and burned in Lake Forest, California. Firefighters had trouble extinguishing the fire. They poured thousands of gallons of water onto the roof of the car. They didn't realize that they had to direct water onto the battery compartment under the car to cool the battery and stop the reaction causing the fire. This is called thermal runaway. Another challenge in Lake Forest was that the battery reignited while responders were winching the car onto the tow truck. New short circuits were created when the battery shifted, causing the fire to restart. The battery reignited once again at the tow yard. A crash in Mountain View, California created a risky situation, managing a high voltage battery fire on a busy freeway. It was a challenge for emergency responders to know when and how to safely move the car. And then, 5 days after the crash, the car's battery reignited at the tow yard. Firefighters were called to extinguish the fire. Even after the fire was out, the battery retained energy and was at risk of reigniting again. The manufacturer's engineers tried, but failed to remove the energy that was left in the damaged battery. This is called stranded energy.
again, as the video noted, some of the safety issues that were identified had to do with how inadequate some of the most of the vehicle manufacturers emergency response guides basically are not doing their job right now. So emergency responders do not have enough or accurate information on how to approach these vehicles after they are involved in a crash, especially when there's a fire and reignitions. So we call for the National Highway Traffic Safety Administration to incentivize manufacturers to follow. They already have international standards and recommended practice on how to present the information and what information to present to responders. First and secondary, it's not just the fire department, but then also the people moving the vehicles at different locations. So we continue to do work in this area. This approach of having a special investigation that gather information for different investigations, mini focused investigation, proved to be very efficient, and also we were able to work with the community to target the message and to reach out to the specific audiences. So this was very has been a very success story in terms of communication approach as well. Another issue that we highlight in this report are gaps in the safety standards, vehicle safety standards, and also in terms of the research in some of the aspects related to this. So what we recommended is we ask, again, as I mentioned, NHTSA to incentivize the use of response guides that follow some of the international standards, as well as continue research on this subject, especially for issues where you have high speed, high severity crashes, which arguably, yes, they're not very common, but when they are, they're very catastrophic. And of course, we have to deal not only with the crash situation and post-crash impacts on the occupants, but then also on our responders. So that's also part of the safety ecosystem. So we are very concerned about that. And lastly, we issue recommendations to some of the stakeholders that are in a position to share this message. So it's not just us going out there. I mean, we are leveraging those resources. So we ask them to inform their members about what happened in these crashes, there are many, and the risks, as well as the tools available to mitigate those risks and what is coming down the pipe in terms of standardization and things like that. Now, the issues that I just highlighted, they're examples, right? So I talk about partial automation, I talk about test vehicles or testing system or prototype systems in terms of automation, and I talk about electric vehicle battery fires. But these are not the only issues that the NTSB is focusing on. So some of the most critical issues that we are also have a lot of body of research or knowledge, they are basically put in this most wanted list of transportation safety improvements. And in highway, we have 5 areas where we are specifically targeting for advocacy. Now, each of these areas, for your awareness, if you go to our website, there is a lot of body of information, as I said, crash reports, as well as numerous recommendations that support each of these issues. So the first area is implementation of a comprehensive approach to address speed-related crashes. Actually, before this meeting, Chair Homendy was having a conversation with several stakeholders on one component of this equation, which was safer roads, and how infrastructure investments and applications are super important to address speeding and also the next subject, or another of the subjects that I will show in a minute. Because another component of this is requirements for collision avoidance system and connected vehicle technology in all vehicles. The NTSB has been issued recommendations for advanced technologies, I think since 1995 or even before that. And we are kind of learning more about it, and we are tweaking these recommendations to hopefully be more efficient in terms of triggering implementation. There is a lot to be done, but we have a lot of knowledge in what is happening in the real world, and we are putting that together in this issue area. Alcohol and drug use continues to be another issue, and it might not be an emerging new issue. Unfortunately, it's something that is still happening. I think what is novel here, or unique, at least from my naive perspective, is that it's not just marijuana or cannabis or regular drugs that are part of the testing. Say, for example, for motor carriers, we're seeing synthetic marijuana and some other drugs that sometimes are not tested for in some of the testing protocols. So this is we have a lot of body of information, unfortunately, seeing this in heavy vehicle crashes, multi-vehicle crashes, and things like that. So another area of interest, and this is the topic that I thought it was going to be number 2, vulnerable road users. We have conducted special investigation reports as well as a research report to address vulnerable road users, including motorcycles, motorcyclists, pedestrians, cyclists. So it's another issue area or another area of interest for the NTSB. And finally, eliminate driver distraction. Again, it's debatable whether these are emerging issues. These are the issues that we are finding again and again. And so for us, it's very frustrating sometimes to identify and see that sometimes there are not a lot of movement, especially when we have a lot of body of knowledge and information in this area. So the most wanted list, as I mentioned, is the top advocacy tool for the NTSB. And after the meeting, maybe I can share some resources with the group, with Don, so you can share with them. Because throughout the year, the NTSB had held events and discussion and roundtables and some other activities to talk about these issues with different stakeholders. So I think maybe it would be beneficial to be part of that conversation as well, or to listen in, because everything is recorded and available online afterwards. I think I'm running out of time, but don't worry, I'm almost done. And I'm gonna actually do my closing here. So just read this for a moment. This is something that is in the back of our minds at the NTSB every time that we go out to the scene and every time that we come back and try to communicate what we have learned and we are doing our advocacy efforts. So I think my message for all of you, the professionals, the students, as you are working in this area of transportation safety, going back to the lessons learned, if you want to go fast, you go alone, you go by yourself. If you want to go far and make an impact, you go together as a group, right? So building coalitions and collaboration is essential, in my view, to understand, to evaluate, and to ensure the safety of emerging technologies, or to assess those emerging issues. So I encourage you to continue doing that as you move forward with this discussion in the next few days. And so I also wanted to point out, in terms of team and work environment and working with teams and groups. So if you're leading a team or you're a collaborator or a staff member in a project, I encourage you to foster trust, respect, inclusion, and diversity of thoughts. I think transportation safety definitely benefit for those type of work group dynamics. And again, it has been a constant in my professional career. So I definitely encourage you to think about that and hopefully implement some of that in your day-to-day work. I also want to mention that another component that I always go back and reflect is to stay true to your values. And that may be out of the sky, but what I mean by that is that transportation safety as a career, sometimes it could be frustrating because sometimes there's a lot of step back or limited funding, or priorities change, or an experiment doesn't go the way we want it. And I think being true to your values and your beliefs will guide you through those difficult times. It definitely helped me through some of the difficult times. And finally, I think my last point, and hopefully something that you will also reflect on, is that I want you all to tell your story. And what I mean by that is that sometimes as researchers, as investigators, we think that people might not understand what we do. And sometimes we oversimplify, or we don't share the full story with people. So for example, when you go back for the holidays to your parents or your family, or if you see your neighbor after a long pandemic, I don't want you to just say, I'm doing simulation work. I'm running human in the loop experiments. I want you to tell them the full story. And I think the full story is that you are solving problems. You are developing tools, and you are generating knowledge. And because of that, I honestly believe that each and every one of you are saving lives as a result. So this is the end of my talk. I really enjoy being here. Looking forward to the Q&A. And I encourage you to participate tomorrow. We have a great series of speakers that I look forward to be part of that conversation as well. So With that, I encourage you to connect with the NTSB.
Wow. Thank you, Lisandra. That was excellent. Excellent. I really enjoyed hearing about your career and how you came to where you were. And of course, warms my heart that a lot of it happened at some of our member institutions. Because I think we make a great family. I'm trying to give people time to think of their questions. And maybe type them, but also, Jacob, did you want to step in and sort of talk about the rules here?
So you can see the full screen.
Yep. Thank you. Thanks,
Okay.
Lisandra. Yeah, so this is open time for Q&A. We encourage all participants to join and to kind of help move things along. If you would like to ask a question and use your microphone, feel free to raise your hand and we will call on you just to kind of keep the order and everything. You can raise your hand in the reactions button at the bottom of Zoom. And then if you no need to use audio, if you don't wish, feel free to type in a question or question in the chat box or comment if you'd like as well, and we'll read that out loud. So with that, I think we'll open it up.
Jacob, Jody has her hand raised already.
Yes, I see that. Thanks for following directions, Jody. We will go to you.
Hello. Thank you, Lisandra. That was a great talk. I'm Jody Plummer and I co-direct the Hank Virtual Environments Lab here at the University of Iowa with Joe Carney in computer science. And we study child and adult pedestrians and bicyclists, and especially how they cross roads with traffic. And so I was interested in your slide about sort of pressing needs and looking at vulnerable road users. And it sounded like you're interested in a safe systems approach. And I might have missed this, but maybe you could say a little bit more about kind of what you're thinking with what a safe system is. And it sounded also like you had a report, and maybe you could make that available.
Absolutely, yes. We have a report which was a compilation of several crash investigations that we conducted, I think in 2018, 2019, for a couple of years, where we were working closely with law enforcement, and we deploy a team as soon as we can. So we were able to be at the scene early on, which is typically not the case for us. And from there, we put a report together. I can send definitely a link, a special investigation report. After that, we draw several conclusions and recommendations. So that report focused on, it was a lot of call for vehicle safety improvements in terms of technology. Adaptive lighting, for example, was one of the topics that was discussed in that report, but then also about data. I think there was a lot of gaps in terms of, and I actually experienced this when I was talking with about the electric vehicle pedestrian research at the very beginning, that exposure numbers and all that data. So we called for the CDC and others to collaborate in data gathering and exchange activities. So that report was done a few years back, and I definitely can share that with you. The safe system approach that Shared Harmony is kind of promoting these days, I think it's not new, especially to the transportation safety, this community here. My interpretation is that basically it's a comprehensive approach to things. So instead of just looking at the pedestrian or blaming the victim, we are looking into all the components, the roadway environment, does that support pedestrian traffic? Providing the funding or the interactions or the infrastructure to accommodate and facilitate that interaction, and the governing principles and regulatory framework that should also support that vision. So I guess it's understanding different components and how that could bring everything together to define issues, as well as to identify countermeasures. And to that effect, I can share a link to the videos of this series of safe system approach that are focusing on, I think we already cover vehicle and road, and there might be other areas that we will be coming up in the near future. I think those are healthy conversations because different point of view for different stakeholders. So I think that might be of interest.
Thank you.
Okay, I see another question. Joe Carney.
There, it took me a while to get unmuted. Lisandra, great talk, much appreciated. So I'm Joe Carney. I work with Jody here at the University of Iowa. I'm interested in, and this is a somewhat ill-formed question, but you raised the issue of driver distraction for imperfect autonomous systems. And that seems like a really hard problem for systems that are 99.9% of the time work to keep drivers engaged and ready to take over when necessary. I'm just wondering if you and others have thought about what strategies there are in order, particularly for this period when autonomous systems are not quite there yet. How to keep drivers engaged and ready to do what's necessary to prevent the kind of crashes that you reported on.
Yes, I agree. So these are definitely a difficult task or different problem to target. I think at the NTSB, we try to stay away of prescribing a way to address a problem. And we basically highlight what we're observing in the field. So that's kind of a distinction between sometimes our research background with what we're doing at the NTSB. But with that said, I think, especially for the Tempe, Arizona crash, we recognize that it's a test system. They are gathering information and knowledge on the roads because that's part of the development. And we are not, it's not that we are opposed to that. I think to the contrary, I think we want them to think about safety first and put those safety management and mitigation strategies in place. Now, the way that they address engagement, there are different ways. Some people use cameras for driving monitoring. I think at the time, some of that was implemented by that company or that operator, but we don't want to be prescriptive in that area. We are highlighting some of the deficiencies that we are observing. And yeah, unfortunately today, right, there are no fully automated autonomous. Tomorrow, the speakers will grill me about this one, but fully capable system to operate themselves. So we definitely rely on the driver. Unfortunately, we're seeing that that complacency and that, it's easy. When they really work very well, you get very comfortable. And I think we will see some of that tomorrow, hopefully during the discussion about what we have observed in the field. But those instances where they don't work, unfortunately, are sometimes catastrophic.
Thanks.
Yes.
Okay, we have a couple more hands. I'm not sure who went first. We'll go to Didier first. Didier, go ahead.
Well, hello, Lisandra, and hello, everyone. How are you? It's very, very nice to see you after all these years and talking about all these issues that are very important and doing the work that we really need for our transportation systems and for the safety of our people. So thank you very much for all your great effort and your work. That's the first thing. I'm very excited, to see you here. So thank you for coming and talking to us. Now, the question. One of the issues that you pointed out in your most wanted list is related to the prevention of alcohol and other drug-impaired driving fatalities and crashes. But we are just scratching a little bit about the influence of alcohol and trying to get another approach in our research. But I think that this might not be a special or particularly high visible or publicly visible issues for traffic safety, but 30% of the fatal crashes in the United States and Puerto Rico are related to alcohol. So I don't know if I think that's a huge enough problem for the NTSB maybe to have to say something about it. And I wonder what if you are aware of what recommendations are there to try to reduce that, at least from your perspective, especially in terms of the VAC, because I think that's something that is important for the system.
Muchas gracias, Didier. Un placer saludarle.
Igualmente.
Yes, so a couple of things. So the NTSB had long been an advocate for lowering the AC level as a legal limit from 0.8 to 0.505. And we try to go to states and do a lot of advocacy in that way to try to change legislation in that area. In terms of the drug issue, I think most of the work that we have done in that area focused on commercial operators, just because of the following the regulations for commercial operators in the United States, especially for, well, either intrastate or intrastate, doesn't matter. But some of the issues that we identify, as I mentioned before, are perhaps the testing programs could be improved, maybe not be as robust, or they're not testing for a wide range of drugs and things like that. So a driver can be clean when in reality, they have things in the system that the program just missed, the test protocol just missed. Happy to share some of the recommendations that are associated with this most wanted list with you, and see, whether there are opportunities to do something targeted at the state level. Yeah, just bear in mind that sometimes, it's hard for me to keep track of all these recommendations, especially when some have had to do with regulation, technology, vehicle, data. It's a lot, but definitely an issue that unfortunately is we are continuing to see that. Now, I'm aware that NHTSA and other state agencies are trying to understand what is happening in their states. For example, after having changes in legislation for allowing some use of recreational marijuana and things like that. So there's some information out there. Again, the difficulty is establishing that percent per se, or that trigger, or that metric, especially for drugs. Like for alcohol, we know how to do that. For drug, to draw blood, and people are kind of privacy issues, and there are other big picture issues that are kind of doesn't allow to move as far or fast. And the last thing that I think is being that we recommended at some point, and we're trying to revisit, are in-vehicle technologies that will prevent people from operating the vehicle in the first place. I know NHTSA, have been working with the DAS program. You probably are familiar with that, where they're trying to work with OEMs and manufacturers to develop this seamless system. When you go into the vehicle, will prevent a driver from even starting that trip. And it shows a lot of promise, but it's not here yet. So.
Thank you.
And then Dawn.
Thank you. I'm going to shift gears just a little bit because I want to key in on something you said about multidisciplinary teams. And it seems to me that these emerging or long-standing issues, or maybe critical key issues that we're all talking about really benefit from that multidisciplinary perspective. And I wonder if you could talk about that a little bit or give some examples, particularly for the students who have joined us, so they sort of understand, because it's very easy when you're in grad school or school to get very insulated and work with just the people you know. And so I was wondering if you could talk about that.
Yeah, so let me see if I can use an example. I can provide 2 examples. Let me just start by my first research that I described at the very beginning, where we have this electric vehicle quiet car situation. We benefited for the multidisciplinary approach because we were dealing with acoustic engineering, the use of sounds to navigate. So we needed to have a perspective and an understanding of how pedestrians perceive sound. That's a very unique niche within psychology, engineering psychology, echolocation, and all that. We reach out to academia, actually, different experts in that area to help us understand, okay, what metrics we should be looking at, what scenarios should we be looking at in terms of pedestrian vehicle interactions. Because we didn't have that knowledge, we just didn't. So another aspect was to go to orientation and mobility instructors and understand how they teach people to navigate when they have visually impaired or some limitations, or they rely a lot on the sounds on sounds. So being immersive in that situation was definitely eye-opening for us to understand some of the questions that we needed to be asking, and then some of the challenges about how do we translate all that perception and information into sound. I mean, how do we define sound, right? Because at the time, and actually ended up being regulation, the countermeasure, and then this could be argued whether it was a good or bad decision, but the countermeasure was to, as manufacturers, require them to add sound, some sound. So we needed to establish the parameters for those allowable sounds. I don't know how to do that. So I have to go to an acoustic engineer. So can you tell me, explain me, how do you define a sound? How do you put parameters? And because you have to define for the manufacturers, you can work within this parameter. This is acceptable, this is not. So it was a lot of learning. I think the benefit of the multidisciplinary approach is you learn what you don't know. So it definitely triggered a lot of new questions as well as new knowledge. And then at the end, your product is more robust as a result, because you hopefully you don't have as many blind spots as you otherwise would have. Now, another quick example at the NTSB, in the case of the Tempe, Arizona crash, we didn't have the super in-depth knowledge of the automation, but what we did have in-house was a lot of knowledge about safety systems and safety management systems, and how to help an organization put parameters in place and kind of what we call the pillars of the safety management systems to mitigate risk. So we were able to share that type of information with the operators, which was a technology-based operation, basically, in the mindset of you are a carrier, you are an operator now. So you need to be thinking about this other, and even that interaction was beneficial. I mean, it was not kind of a team research environment, but it was kind of cross collaboration, different perspectives. So that work not only focused on the system, as the technology didn't, you just, yeah, that's what I say. You need to read the full report, because a lot of that was the system was not able to detect certain things with a certain time frame, and those things are important. This is just kind of the probable cause, but there were a lot of information derived from that investigation. But in addition to the system, understanding of the system, we were able to bring kind of that safety management perspective into the picture. So again, different area of expertise provide a lot of valuable information. So
Thank
breaking
you.
the silos. I'm all for breaking silos.
Yes. Thank you. Thank you very much.
Well, in case you were wondering, about my boyfriend, I mean, before we get all the questions, don't worry, it worked out very well. We found each other and we've been married for a long time. I have a beautiful daughter. So in case you were wondering, just
Congrats.
filling out some space here, Jacob.
Well, I was going to say,
It's true.
my question was, can you share an embarrassing story about Dr. Colucci or Dr. Nodler or Dr. Noyce? But no, maybe we don't need to do that.
I will never do that. I do remember Dr. Colucci took a lot of photos everywhere.
That hasn't changed. We've
Okay,
captured
that's
some
good.
good memories when we've been able to do this in person. So
Hey, again, that was I just want to highlight, and now some of them I know are on the call, so I want to say thank you and tell you that each of you were very influential in my career throughout undergrad, graduate, even after. I know some of us have been kept in touch throughout our career, so I sincerely appreciate that, and I try to do my part to help others as you did help me. So thank you.
I have a quick question maybe to follow up with that. And I know I saw in your longer bio that you had an interest in the STEM fields. And I'm thinking, maybe from our researchers' perspectives across the site, what can we be doing to help, draw those undergraduates, those graduates into a career in transportation so we can continue addressing these issues moving forward and as this technology continues to rapidly change?
Yeah, thank you for that question. I think definitely there's a lot of opportunity for everyone, especially those that are students, because you are closer in age. People still see you as a young person, maybe. So you have a lot of influence. You don't know that, but especially in many situations, in my case, I'm very passionate about bringing women and minorities into this field. And, sometimes if people don't have role models in terms of if they never seen a female professor or if they never seen a researcher that looks like them, they don't see themselves in those positions. So I think sharing it happens to me. At the beginning, I thought I didn't know anything, but you would know a lot and you have cool story to tell them. So I would encourage you perhaps to partner with local high schools and even younger students, because I think they are thirdly for knowledge, but then also for role models. So that's one way that I think it could be a lot of benefits. I definitely volunteer a lot with the community itself, not necessarily at a school, but maybe with a community center if they have, say, programs for younger or youth at risk, for example. I try to go and talk about crash investigations, and they get all excited about this potential. They didn't know that people have that as a job. So those exposing them to the realities of what we do and the impact that we can have, I think is a good motivator for the youngest generation.
Thank you. And I will say, I know a lot of our sites are already doing that. They're organizing their own events, partnering with those local schools, or inviting schools to our labs to kind of share that stuff. So that's great to hear.
Yes.
And I will remind people that's why we ask for it in our semi-annual progress reports, because we also want to share what we're doing.
But that's awesome. And I want to add a little bit about that. Just in addition, I don't know exactly what all you are doing, but I realize that sometimes in addition to a talk, for example, at a school, some of the things that are being very impactful is reserving a day to talk about college applications. Some in the community that I work with, sometimes they're first generation college students or aspiring college students. So just the fact that you can assist them in providing, what you try to build your extracurricular activities, try to build your kind of your resume as a high school student, So you are in a better position to apply for these different schools and how to go about it, because sometimes it's just lack of access and a lack of examples. So there are a lot of things that we can do.
That's great. I do see another hand that has been raised. Dr. Colucci, let's turn it over to you. And Dr. Colucci, you are muted.
Okay. Thank you, Jacob. Spectacular presentation, Lisandra. A big hug. Un abrazo de Puerto Rico.
Gracias.
And the question that I have is, if you can help us at the university setting, okay? What suggestions, based on your experience from Puerto Rico to whatever years ago and UMass and now in the NTSB, what suggestions can you give to the academia or the universities in terms of considering making changes in their academic programs, curriculums, or topics that should be considered to address this passion in transportation and get more involvement of our students? And any suggestions beyond the academic perspective? I used to be a former dean of engineering, something that can help us, the administrators, to improve our programs, in addition to traditional ABET, Accreditation Board of Engineering and Technology. What other skills, what other suggestions you have right now that, look, if I could make the difference nationwide, I will give A, B, C, this suggestion for considerations to the academic senate, to the director, dean, or whatever.
Yeah, thank you for that question. I think some of the thoughts that I have in that area is that there are definitely skill sets and transferable skills that we need to foster and that we can foster as, say, undergraduate or graduate school, because sometimes we are often too focused on the technical aspects of our career, which is important. But for me, I think part of this was a compilation of my experience at UPRM, at UMass, and then in the workplace. Communication skills, exposure, and opportunity. Like for me, as you all know, I'm very shy. I don't know if that comes across, but I am very shy. And when I started working at the DOT, I was oftentimes the only female that looks like this. And it was challenging for me to find my way in those spaces. So I think mentoring programs, either formal or informal, are also good, because I think from my perspective, some changes and some awarenesses on how I should be more out there and show that I have this capability and not waiting for people to, to see me, but kind of to be more out there. And then as a supervisor or as leaders, giving those newer generation the opportunity to be in the spotlight, managing the risks, because of course there are risks. I remember one of my supervisors, he just took me to the Secretary of Transportation office and said, "You're briefing the secretary tomorrow. No slides, 5 minutes, this thing." I'm like, okay. Of course, I was super scared, but to me, just the fact that he trusted me with that message, and I knew he probably was not super 100% sure about that, but it just gave me a lot of confidence. So a lot of transferable skills like that, communication, empowering people. In terms of the curriculum, to be honest, I'm not as involved in that arena. I know some of you are in committees and things like that, so I don't feel that I have kind of a lot of knowledge in that area. But what I saw and experienced was, as a graduate student, I started that multidisciplinary formation, if I will, is at that point. At that point, my faculty advisors encouraged me to have that thinking of, what you know about civil engineering. You need to learn about psychology. You need to know about statistics, experimental design, entrepreneurship, how to go to the city of Northampton and ask them to test this thing and get it done, So it was a lot of experimental, but being practical as well. I think for me, I also had the chance to manage research projects for NHTSA. So assigning funds and then tracking the work from different research institutions. And if I can identify a few things to learn from that experience in terms of helping academia is to understand the decision-making process at the state or federal level, because that would drive kind of the effect that how your research could be used. I mean, eventually we want to give money, but we need answers, we need decisions, we need to be informed. So how can we kind of bridge that gap about being purely academic and perhaps, you know, the impact is not as clear, or the risks are not well understood. So with having that conversation about how can we help you, help me, and then kind of meet in the middle. If that makes sense. A lot of you have more things to add to these conversations. I'm welcome.